Right. Hello, my name is Yukino, and I'm from Keio University in Japan. And I am the first year in my master's, so I am quite nervous. It's my first conference. I will be presenting. I will be presenting under the title "Simultaneous Measurement of Respiratory and Pulse Information Using a Patch-Type Sensor for Sleep Apnea Hypopnea Detection." So, sleep apnea hypopnea syndrome, otherwise known as SAHS, is defined as recurrent episodes of restricted airflow during sleep, and you have higher probability of having this when when you're obese or you're old or you're Asian. And common symptoms of these are daytime sleepiness due to lack of sleep and heart problems. The most common way of screening this is called a PSG, and it can measure multiple biosignals, including heart rate, respiratory rates, blood oxygen saturation, otherwise known as the SpO2, and sleep levels. However, as you can see in the figure on the right side, it involves a lot of sensors and wires, so it is very invasive and costly and requires a lot of operational skill. For its complexity, more than 80% of moderate to severe patients remain undiagnosed. So there's a rising demand for accessible, non-invasive, at-home screening systems. It may seem like it's your respiratory system's problem, but there is a huge effect on cardiovascular systems as well. When your breathing stops, there are no exchange of oxygen and your SpO2 drops, causing hypoxemia. So your body is in danger, so sympathetic nerves get activated and it orders your heart to pump faster to get your circulation going. And then once your lungs are out of breath, you gasp for air and start breathing again, and your heart rate slows down. This repetition of hypoxemia and reoxygenation causes oxidative stress on your blood vessels. So the patients have 5 times higher risk of cardiovascular complications. The simultaneous measurement of respiratory and cardiovascular information is really crucial. Here, I want to propose this new sensor that I am working on with a company. It's a patch-type PPG sensor. You can directly paste anywhere on your skin, and we believe that there is a potential to measure pulse and respiratory rate at the same time. So I'm pretty sure I don't have to explain the mechanism of PPG sensors to you guys. I think you guys know more than me. But so this sensor emits infrared light into the blood vessel, and depending on the blood volume, the photodetector, the amount of light photodetector detects changes, composing the pulse wave. So here we show this example of pulse wave that we have. The middle is the proposed, and the top is the reference of respiration, and bottom is the pulse. As you can see, the big wave represents the breath and breathing, and the little waves represent the pulse. And here I would like to introduce you guys to a previous work by Nakai's team. They put PPG sensors on their fingertips and foreheads and tried to discover where the optimal sensor position for SpO2 and pulse rate measurement. And they found, so the red is the forehead and the blue is the fingertip. They found out that the faster and bigger changes were seen on the forehead more than the fingertips. And degree of change in SpO2 differs depending on the position of the sensor. And they have concluded the sensor positions closer to the heart is more optimal for easier and real-time monitoring. And the second point that they've found is that when the patient is under apnea, it is SpO2 going down and pulse rate rising up was observed, as you can see over here. So we believe if this relationship between the SpO2 and pulse rate is found also on the chest, we think we can also estimate SpO2 from the pulse rate patterns. And also we can use this information for credible detection of apnea and hypopnea. So what do I actually mean about credible detection of SAHS? So I will explain this under this case model. The orange background signifies where time under hypopnea. Hypopnea is not the complete arrest of breathing, but they have low ventilation, so it's also dangerous. If you're using respiratory information only, you probably know that there is a decrease in amplitude, but you're not sure if it's like normal or hypopnea or maybe a sensor malfunction. But if you actually use pulse information at the same time, you can, if there is a relationship between the SpO2 and the pulse rate, we believe that we can estimate oxidative stress on cardiovascular systems from the pulse pattern. So we can see that while SpO2 drops and pulse rate rises, while under the time in hypopnea, we can be more sure, and we have more evidence that during this time it was hypopnea. So this is my image of a final application goal, and we aim to do this in the near future. But for this paper, we have a different research objective. Above all, we have 3 needs for this this problem, and we believe that this new patch-type PPG sensor can solve it. And we propose measurement on the chest for better SAHS screening. And before although my final goal is to develop an algorithm to detect SAHS, first I think we need to confirm these 2 hypotheses as an initial study. The first being chest measurement enables simultaneous measurement of respiratory and pulse with a single sensor. And number 2 being chest, we can offer more credible and real-time monitoring, and also at the same time show the same cardiovascular relationship that was observed on the forehead and the fingertips on the chest as well. So here are the experiment conditions, and we had 2 subjects for this, and they were both in their 20s, and we had the patch-type PPG sensor placed on the right side of the sternum and had the patients lie flat on the floor like this. And the apnea simulation experiment went like this. We've asked the subjects to breathe normally for 60 seconds with no specific direction given. And after that, we've asked them to hold their breath as long as possible after a 3-second countdown. And we've made sure they didn't take any extra inhalation before the start of the apnea. And then after they went to their limits, we've asked them to breathe normally again for another 60 seconds. So now we will explain about the overview of the analysis. This is the raw signal that was obtained from the sensor. And then we performed time frequency transform, specifically synchro squeeze transform, to visualize components for extraction of respiratory and pulse information. And then we used the possible respiration and pulse range that was given by a related work and developed a different 2 algorithm for each information. So now I will explain about the respiratory information. It was said to have the possible respiration range was about 8 to 54 BPM. So we've applied a bandpass filter between 0.14 and 0.9 Hertz. And then after that, we've performed peak detection under these conditions. And the result, if you look at the raw data comparison, similar waves were observed, but you can see that we had a very high mean absolute error for both subjects. This is because my peak detection algorithm requires more improvement, which I am working on now, and it's getting better. So maybe in the near future, I'll present again. And now for the cardiovascular information, it's similar, but we searched for the maximum peak frequency between the range that was given by the reference. And then when we searched for it, you can see the highest peaks are over here, and we can see the algorithm successfully found where it is, but there were a lot of outliers, so we removed them using the fill outliers previous function in the MATLAB 2023. Then we gained this figure on the right, and then we used this to calculate the pulse rate for every second. And here are the results. The average MAE was 1.47 BPM, excluding the failed attempt. But given the fact that Samsung smartwatch average MAE is 1.06 BPM, we think that we have a comparable result. And the reason for poor estimation for the 2 of the trials is because the signal strength was too weak to find the peak of the pulse rate. And also my outlier removal algorithm was not perfect. So we're planning to make some improvements there. And for the second hypothesis, we wanted to confirm the cardiovascular relationship between the SpO2 and pulse rate. On the top, we show the SpO2, and the bottom is pulse rate. Red shows the signals that we've obtained from the chest with our proposed sensor, and the blue signifies the fingertip of the reference sensor. As you can see, red comes before blue for all of the results, which signifies that chest reacted faster to changes than the fingertip, which matches the result of the related works. And also, for 11 out of 12 trials, we were able to see SpO2 go down and pulse rate rise under time of apnea simulation. The one trial that didn't work is shown in the bottom right. As you can see, the apnea simulation was 27 seconds, which was really short. So it was too short for the SpO2 to change. That's why we couldn't observe the relationship. But this also means that short apnea can be detected using the pulse. So it will contribute to credible SAHS detection. So to conclude, we've confirmed that simultaneous measurement of respiration and pulse is possible, but improvement in the algorithm is needed. We also confirmed that chest allowed more real-time monitoring than the fingertips. And also, we were able to observe a relationship between SpO2 and pulse rate on the chest as well. We plan to use this for estimation of SpO2 changes from the pulse rate patterns and utilize for more credible detection of apnea and hypopnea. For future works, obviously, improvement in estimation algorithm is needed, and it is going better now after the submission of this paper. And we also plan to expand the range of subjects since we only had 2 subjects and we have a lot of work to do. Also, my final application goal is to develop SAHS detection algorithm. So I'll definitely do that. And also, we've observed some patient variations. So we hope to find personal parameters for more accurate detection. I'd like to thank my professor and my lab members and collaboration, my collaborators, and also you guys for having me here. It's my first conference and I was really nervous, but I got to learn many things and I enjoyed my first Europe. So thank you very much.